got an extra 4 weeks on base.
Oh, nice.
So this summer it should be 12 weeks on base.
Okay. Yeah, like I said, I actually got the offer, but I'm gonna, I don't know, I'm still looking.
Yeah, it depends on, honestly,
Guys,
my
can
problems.
you,
Oh,
guys?
yeah.
Yeah.
Oh, hey, welcome back.
Yeah, did my, I don't understand what happened. My,
Maybe your internet dropped or something.
Huh?
So maybe your internet dropped. You just like left the room.
You think? Okay, so it was my internet. Okay.
Yeah, we've been just kind of sitting here talking.
All right, I'm sorry. I couldn't.
That happens.
It's okay.
Yeah.
we all know technology fails from time to time.
Yeah. This. All right. Well, I'm glad. So it must have been my internet thing.
Josh got promoted to host, by the way.
Yeah, he was going to teach Weka.
Well, I'm no longer host, so it's fine.
Darn.
No, as soon as he joined, he became host again.
Okay. All right. Thank you.
I was host. I would have kicked Josh right away. That would have been fun.
So let's move in then to the topic. So again, hopefully. So is it recording?
Yes.
Right?
Yeah.
Okay.
It says it is, yeah.
Okay, great. All right, so let's continue then. Okay, so as I was saying, we're going to start with Weka today. These are the data sets. We're going to use data sets. There are basically many types of data set formats out there. The main ones that we're going to use are CSV or ARF. All right, so to start with, we're going to start with CSV as the most intuitive one. And then ARF is a little bit more complex, but it's just, as I was saying, the native Weka extension. So all Weka files, data files are, ARF. It's a little bit more complex. Sometimes when we have a .csv file, we're going to have to convert it into ARF. But that's easily done in Weka itself. So Weka has a lot of functionality for that, and we will see. All right, so what is a sample? So, I've used the word sample. I want to define it. Whenever you have a problem in machine learning, the first thing you need to do or you want to do is define the sample. What is your sample? So for instance, I'm trying to classify pictures of cats and dogs. So each image, which might be 100 by 100 or so, is going to be a sample, okay? And these samples then need to be represented in some way. Keep in mind that that image might end up being in a multi-dimensional space, right? A simple dot, where every dimension of it is basically called a feature, right? It's every dimension of this space represents a characteristic of that sample. So we'll talk a little bit more about that as well. This is a concept that it doesn't come easy. Okay, don't expect me to just like give you a definition and that'll make sense. It'll take a little bit of time. One way of thinking about it is, as I said, think in terms of 3 dimensions, think in terms of 2 dimensions, right? So you represent, a tree. Is it a tall tree? Then it's tall. And is it a tree with flowers? A lot of flowers. All right, so those are the dimensions. Okay, and so you have some trees that are not very tall and don't have flowers, and then you have trees that might be very tall but don't have flowers, and then you have trees that have a lot of flowers but are not very tall, and then you might have trees that are very tall and have a lot of flowers, and anything in between, right? So that's how you represent the data in these spaces. You add a 3rd dimension, and now you represent it as tall, flowers, and what's something else about a tree? The stem size, right? So is it, large stem, small? And so, the root system, actually. Let's say the root system has got a lot of roots, deep roots, or not very deep roots. So now it's 3 dimensions. But what if you had a 4th characteristics for the tree? It's tall, it has flowers, it has roots. And now what's another thing for a tree that might help us to group it? You guys still there, or did I leave the room again?
You could use its leaves.
Leaves, right? Something about the leaves. Does it have really big leaves? Does it have small leaves? So that would be a fourth dimension. Keep in mind, humans are not capable of visualizing things that are outside of three-dimensional space. But mathematically speaking, that fourth dimension here, this fourth axis, is basically perpendicular, right? So the key thing is that when you have a Cartesian, 90 degrees, we know that, right? We learned this in school, 90 degrees. That's called perpendicular, right? Then we have a three-dimensional one, and we just know that this one comes up, right? So that would also be 90 degrees to the other two axes. The fourth one here would be also, even though we can't pick, I can't draw it now anymore as a 90 degree or even imagine it, it is a property that does exist mathematically speaking, right? And that term, the perpendicularness or the 90 degree-ness of this just translates into a term called orthogonal. So the base is the basis vectors of this space are going to be orthogonal, and that's just it's one of the basic principles of the structure that we're using here. You don't have to worry too much about it. Instead, what you might want to think about it is that things are independent, right? So this vector is independent from this one because it's 90 degrees, right? There's no projection to it. If it was this, and then I have a vector like that, I can project this vector to that other space, just like I can project this vector to that other space. So it's not independent in that sense. And that's one of the key ideas that we will consider. But don't worry about it so much. Just remember that we need features to represent, like I was saying with the tree, represented. And a lot of the time, we're going to try to represent things in this space. Okay? Questions? All right, so some examples of samples. A single item could be, for instance, text, right? Let's say that, a sentence, a tweet, a document, a paragraph, a couple of words, all of those could be samples, and we just have to learn how to represent it for machine learning. Okay, just like I said, a tree or, so on. An image, that's a common one, right? We know that, has become very important because, Google and everything, we type in something, we get images. So they need to give us the images that we need to see efficiently so that they can make money. And so they've spent a lot of research on that, right? And then other things, there are many other things. It could be like abstract things, like the number of elements within a time window. So for instance, in networking, you want to analyze, build an intrusion detection system. So you might want to analyze things at the per packet basis, but you could also say, well, one packet doesn't do this problem justice. So what about, I look at all the packets in a time window of, say, 1 second. So all the packets that I have there, and then I kind of take the average of that, and then that's my sample. Does that make sense, guys? So the point is, you can really model any problem, literally any problem, as a machine learning problem. You just have to think about it a little bit, make some simplifying assumptions, and so on. Okay, that's samples. Data sets. Today there are many data sets out there. Usually I'll provide links. As I said, we're going to use some data sets maybe from Kaggle, from UCI. I have some on my website. I have some on the VM that I gave you. And sometimes you'll create your data sets. Okay. Today, we're looking at the IRIS data set. There's, of course, MNIST. I've also provided a link. I think I've shown you the link already. And there are many more. A lot of these, some of these at least, are in the VM that I referenced. Okay. So this, yeah. So that should just say companies using, oh no, that's correct. I'm sorry. Companies using machine learning, as you know, Google probably the biggest one. You know, Facebook. I don't know what Facebook does really. So they have machine learning there. There's Apple, you know, your iPhone, right? Siri. Okay. So that's definitely something important. Amazon, Alexa. Have you noticed, for instance, I want to see if you guys have ever noticed. Have you ever noticed let's I was gonna say show of hands, but let's say some of you have Alexa, correct? You know, at least a little remote, a Fire Stick, I think it's called. Right, so I assume that's, yep. And have you noticed that maybe you're watching the Fire TV or whatever that's called, and at the very bottom it says something like, tell Alexa, hey Alexa, you know, who was Tchaikovsky? Have you seen that? Or it says something like, say to Alexa, hey Alexa, who's playing, you know, on Monday Night Football, right? You've seen that. Well, if you notice, it's what they're trying, one of the things they're trying to do there is not just that they want you to learn about Tchaikovsky or the football. What they want you to do is they want you to train Alexa, because so they're basically using you as an employee of them to improve their machine learning algorithms, because what they want to do is they want to get your audio. They know what text you're going to say, because it's likely that you are reading the text that they wrote down there. And so they will have the sample, which is your speech, and they will have the text which they just told you to write, to say. And so they can correlate that speech to that text. And given that, imagine now millions and millions, or not millions, but thousands and thousands of people all over the world doing that, right? It basically, they're all providing samples of audio and text to train Alexa. So that's a very good example of machine learning being used for Alexa. As you know, Amazon, and I should have had Netflix in here. Netflix use recommender systems. I mean, that's very obvious. And so on. Microsoft, they're a little less known for AI, but I can't think. Anyone know something that they're doing in AI? Any products that they have? I'm sure they have something.
Yeah, I think Josh said it. I was going to say, don't they have Cortana?
Cortana. Oh yeah, Cortana. That's right. Yeah, it's like a Siri. You're right. I think also their new flight simulator just came out, and I'm betting it's got, or their games. They have a whole games thing, so they're definitely doing AI things and maybe possibly machine learning things. Okay. They have an AI library that is okay. Oh yeah, to .NET, right. I think they had a Twitter bot, but it got shut down. Okay. All right, so yeah. Good. So those are some of the companies, you know, more opinions. They have an IoT. Okay, great. Yeah, so they're everyone's working on it basically. All these big companies, they want to move into that domain of you know, like Google, and so they have a lot of interest in this. And that's not just them, right? There are companies in other industries like cybersecurity, for instance. There's Northrop Grumman, right? Blue Vector is a company that is in the intrusion detection system. Banks, you know, because they need to provide security for their systems. Healthcare is another field that has a lot of this as well. All right, so that being said, now let's get into Weka. We have enough time to just play with the Weka program. So just as a reminder, all my code is available on the GitHub, so you can just go there and download it later on. You know, I've talked about this already. We'll be using these tools. Here's some information. I leave it to you. I think I had promised that I was going to show you some information on how to build a physical machine. If you can afford to get the RTX 2080 Ti, I think there's a VRAM of 11 gigs. And that's just going to give, that's like the most common now. That's affordable. These Titan ones are very expensive. You know, as many cores, get enough watts to support multiple GPUs later on. So 1200 watts or 1600 watts even. Motherboard that supports multiple GPUs and CPUs. 32 to 256 RAM. SSD hard drive, you know, 1 terabyte, and then maybe get an additional, you know, a hard drive, or you can get one with 2 terabytes. And the coolant case with cooling. And it's gonna run you more expensive nowadays, 2,500 to 3,500 to start. So it's pretty expensive. You don't have to buy it for this class though. That's why we are trying we're gonna try hopefully the Scholar. I've been receiving a lot of emails about that. So hopefully we will have that going at some point. All right, so that's if you want to build a physical box. Those are some of the places where you can start. I'm sure you guys know a lot about this anyway. All right. Okay, so that's pretty much it. Now I'm going to start up Weka. So I'm going to assume that you guys have already installed it. I'm also going to download the file. And we're gonna start there. I'm just moving the file to my, oops. I'm gonna move the file to my, sorry, I'm in the background just moving things. Sometimes I can't get this zoom out of the way. Okay. All right, so I'm going to share now. I'm going to share. The screen. Okay, so first of all, can you guys see the website right now?
Yeah.
Okay. So the first thing you need to do is go to the website for 520 and download this file, Fisher's Iris. Okay, so download it to your computer. That's the first thing. Then I just downloaded it to my desktop. Then I opened the Weka program and it looks like this. Can you guys see a little hovering window that says Weka on it?
Yeah.
Okay, great. So that's what you should open, okay? That's the Weka program. It's got that little menu there. Now notice it's got these, I think it's called the Weka bird, that's why. So it's got these 4 options: Explore, Experimenter, Knowledge Flow, Workbench, and Simple, you know, like Terminal. We will mainly use the Explorer because that's really what we want to do. We're not going to be using Weka for solving all of our problems. Instead, you know, we want to code as much as possible. But whenever we want to prototype, okay? So if we want to prototype, Weka is a good bench for that. So it's a good workbench or a good benchmarking tool to prototype our data. So Explorer will be that. As the name implies, you go in it and you explore the data. And that's what I'm going to show you today. And the time that we have left is really just, all right, how do we do that? How do we quickly, that's one thing I love about Weka is I can really quickly just get going. Usually what's going to happen is you have a problem, right? You have a problem, Twitter data. And you spent hours and hours writing Python code to process the data, to get it into the format. And now after all those hours, you're done. You finally have your file. It's ready to go. You're really tired. Do you really want to sit down and now start writing machine learning algorithms? No. You're eager to look at your data and to see, okay, did I do a good job with this? What's going to be my performance? Just really quickly. And so even if you only do that with a small subset of the data, you always want to do that. And that's one of the great things that I think, in my opinion, Weka is really good for. It's just, when you're in that last hour and you're really tired, you just run your Weka and it gives you a really comprehensive picture of a lot of things. Okay. So that's it's fully GUI based, as you can see, is a GUI base. So we're going to use the Explorer. Additionally, we have the Experimenter, and the Experimenter I will talk about later. It's good for people when you're submitting papers and people want to know. So for instance, whenever you have a problem, right? One of the things that you will say is, okay, I ran these 3 machine learning algorithms, and I think this one is better than the other 2. But then there's going to be someone in the audience that says, and you probably heard this in a class, right? You heard it before. And they're going to say, oh yeah, you're saying that A is better than B and C, but is that result statistically significant? Have you guys heard that expression before?
Yes.
Yeah. So that's what's gonna happen, right? Is that the question is gonna be, you have a result, but is the result statistically significant? Did you do so what is called a t-test, or did you do something like that? And so that's what the Experimenter is good for. It's good for trying to answer that. Now you can always just do the t-test on your own. You can just write the Python code for it. But here it is built in. But for now, we're not going to worry about t-test or anything like that. We're just going to do the Explorer. So let's, the first thing we want to do, I already have my file on the desktop. The CSV, remember, it's going to open it because it's got a CSV. If you're using Windows, if it's got a CSV extension, it's going to open it as you want to open it as an Excel file, right? It's going to want to open it as an Excel file. What I like to do is I don't want to open it as an Excel file. You can always open it as an Excel file and modify it that way. I'm not saying it's not right. I just have a habit of wanting to see it as a text file. And so what I can do is I'm going to click on WordPad, right, and open the file with WordPad. If you go to View in WordPad, there's something called Word Wrap, and so wrap to window, and it just makes it more like a text file, intuition, and I just it's a preference of mine.
Hey Calix, if you're trying to show us what you're doing, because you're sharing the main Weka window, we can't see anything else.
Oh, okay. Let me switch over. Okay, I'm going to switch over to the file. Can you guys see the file now?
Yes, we can see the file.
Yeah, and all I did is, I downloaded the file, right? In my desktop, it looked like an Excel type of a file, but I right-click, right, and then pick WordPad. And then I just went here to View, and then Word Wrap, and then select Wrap to Window. Okay, that's all you have to do. And then you have the file now. Why is it that everyone starts with Iris? Because it's very easy. It's very small. And so it allows you to identify a lot of things really quickly. So first things first, what is the structure of the files, the basic structure that you want to have? So in a CSV file that you're going to feed into Weka, you want to have, the first thing is the heading here. You can see there's 5 things separated by commas. So there's, you can call it the column name. So sepal length, that's 1, sepal width, petal length, petal width. So they're really just 4 characteristics of a plant, okay? And that's what Fisher was doing. Fisher collected 150 samples of 3 types of plants, and he collected 50 of each, right? And he was measuring them, you know, by sepal length, sepal width, petal length, petal width, okay? And that apparently distinguishes the species of plant. You can see that the 5th column is species. All right, so that's like saying that's the label. I'm gonna take those 4 measurements of 150 plants, and based on that, I will be able to use machine learning that whenever I get another plant that I haven't seen before, as long as I measure the sepal length, the sepal width, the petal length, petal width, and I feed the data in that order to the system and to the model, I will be able to predict the species of the plant. Does that make sense, guys? That's a very important concept that I just mentioned, so I want to make sure that's clear for everyone. No questions?
Not so far, no.
All right, great. All right, so then you can see then so now we have each row is a sample, okay? So the first row is some plant, and the sepal length is 5.1, sepal width is 3.5, petal length is 4.0. Oh, sorry, it's 1.4. And then the petal width is 0.2. And the label is setosa. So that means that the plant, those plants that have that characteristic are setosa plants. Then you can see that's the first 50. Then the next 50, you can see here I have 3 samples, 3 rows, and they're versicolor. And now they have those types of measurements, which will be a little bit different. And that's 50 of them. And then finally, the last 50 are, you can see I have 4 samples here, right? And these are classified as Virginica. So if I just grab a random sample here, the comma separated values are 6.5, 3.0, 5.5, 1.8. Make sure you study this file really well, okay? If you notice, you know, there's no, the cursor cannot go further down here, right? Notice how this is formatted. Formatting is essential. Otherwise, you're going to have errors and things will just not work. But it is safe to say that for the very beginning, any problem that you have, you should always grab your data set and create a structure that looks like this one. So the label will be the last one, okay? Okay, so that's the basic idea. So again, I'll repeat, whenever you're thinking of a problem, you know, networking or a supervised learning problem, right? Classification, associate features to labels. Always think, okay, what does iris look like? Okay, it looks like that. So I need my data to look like that, right? That's like an essential insight into machine learning. The easiest, as you progress with this, obviously you're going to learn more and you're going to become, you know, better at it. But this is a great starting point. Make sense? Okay. All right, great. So now that we have our file, it's ready to go. This should be ready to go in the format that we need. So now we can just go ahead and proceed to the program. So I'm going to go back I'm going to share with you guys Weka again. Can you see the Weka? You should be able to. Now I'm going to click on Explore. All right, so now that I clicked on Explore, do you guys see a new window that popped up? Or do I have to share that?
No, we cannot.
No, we don't see it.
All right, now you should see it, correct?
Yes.
Correct.
This is the Weka Explorer, okay? So this is the program that we use. The simplest way. My goal today is for you to learn how to use this so you can apply it as part of your homework assignment. Okay, so what do you have to do? So there's a lot of features here. All right, so you can see here, there's pre-process, classify, cluster, associate, select attributes, and visualize at the very top. Those are the tabs, and those usually translate to different things that you can do. So for instance, we talked about unsupervised learning, that's cluster. We talked about supervised learning, that's classification, okay? And then there's the other ones that we will talk about later. So if you notice, here we have these buttons: open file, open URL, open database, generate. So as the names there imply, those are the buttons that you press when you want to load your data. So for the most part, we will be using open file because I already have a text file in a .csv file in my desktop, right? Now, if you look down here, usually what's going to happen is here you're going to get some information, some statistics about the data set. Over here, you're going to get a list of the attributes. And then over here, you can click on an attribute and get specific data about each attribute, right? So every attribute will have some values, and those values have a mean and a standard deviation. Okay? All right, so let's get, and one last thing I should say is if you look over here, you got this long text box that says filter. So a lot of the time you're gonna have data and you need to modify that data a little bit further, all right? You need to apply what is called a filter. You're gonna take the data and maybe you wanna get rid of, value, it's got missing data, so you wanna convert those into zeros, all right? So there's a filter for that. The filters in Weka are quite extensive, so there's a lot of filters, okay? And so we'll talk about some of those concepts, in particular oversampling and undersampling later in the semester. For now, we don't have to worry about that. However, you can always just explore what's there, okay? So what's the first thing we want to do? The first thing we want to do is open a file. So I'm going to go to the desktop. I'm going to scroll up to the desktop, and I'm going to click on, okay, so it should be on the desktop, but I don't see it actually. And the reason why I don't see it is that I'm looking for files that are extension .arf, and my file is currently not .arf, but instead it is a, what is the extension?
A CSV.
CSV, right? So I have to click on this, right? And I'm going to look at all the data types. So there's, all that, JSON, so on. Well, let's just do all. Okay, and now we have all the files here, and there's my CSV file, so I'm going to click on it. All right, so I click on this, and now iris.csv, you can just press open, and there you go. You should probably follow along so that if you get stuck, because you remember you're going to have a homework assignment about this, which will be pretty much just what I did today. Are there any questions about this?
I do have one quick question to see if it does matter or not. So the VM that you gave us has Weka in it already, but it is not as advanced of a version as yours. It is missing one thing in the applications tab. It does have Explorer and Experimenter. I don't know if we're going to use the other three that you have there so much. But then outside of that, everything else is pretty much the same except for species. It says classes. So.
Right, yeah. So yeah, the VM is just for convenience so that you have everything there. You can always just install it on Windows. It's really up to you. That's a great thing about this is that you can always have multiple approaches. All we're doing what I can tell you is probably every Weka anywhere will always have the Explorer. It's been around for at least a decade or more. All right, so now that I loaded the data, I don't want to apply any filters yet, but I want to look at, remember the columns, right? We had sepal length, sepal width, petal length, petal width, and species. So notice that, for instance, I clicked on species, that's the label. And notice that over here, it says class. It identified, because I put it last, right? It identified it as a class. And notice that there's 50, so it's giving me a histogram of the number of samples. So there's 50 blue, 50 red, 50 light blue, right? And that just means that I have 50 samples each, right? Another thing I can do is I can look up here, Setosa virginica versicolor, and it shows me the count, right? And so it shows me, different information. If I want to look at, for each feature, I want to look at the minimum, the maximum, the mean, the standard deviation. You can see that there, right? And here is another histogram of the data per each class as they are grouped. So Weka is really good at that. It just gives you all this information really quickly. You can click on individual ones. Now, data types. Weka has two main data types that are going to cause you problems later, especially when you create your own data. If you're doing a supervised learning problem, then the feature, that's the label. If you look over here where it says type, needs to be nominal. Okay, so that's a very, very important element that you should not forget. So your labels for supervised learning should always be nominal. Now, if you look, the features, 1, 2, 3, 4, those should say numeric. They're numeric values. And what that implies is that the labels, the labels are not a numeric range, but instead they're nominal values, that indicate classes necessarily, but there's no, reason to think that 2 is somehow greater than 0. They're just classes, okay? So that's an important distinction that you should always be aware of. If I can check on a feature, for instance, and I can remove it, although don't remove it, but you can. It doesn't remove it from the file, it just removes it from the memory representation that we have here. Now, another thing we can do with Weka is if we want to, let's say this is a CSV file, right? That's what we loaded. But we want to convert it into ARF. It's very easy. Just click on Save. When you click on Save, change the extension, and that's it. Save it to your local computer. Edit is a nice, handy thing, although it's difficult when you have a really large file. So when you have a really large file and you want to modify things, you probably want to use the filter or write your own code. But here, we can quickly just take a look at our data. You see that? All right, in the edit window, I'm going to close that. And that's pretty much it. As I said, I don't want to get into filters right now because it's quite complex. I will say you click on choose, click on filters, and then you have filters that apply different kinds of algorithms. You see that? There's a lot of algorithms. So a lot of algorithms. See that? Lots of algorithms. Nominal. For instance, let's say that you loaded a data set and the data set, the label appears to be numeric, but you need it to be nominal. Then you would pick the numeric to nominal filter. You can see that down here, right? You select it. Once you select it, you would click, this is kind of like not obvious, but this is how Weka works. Once you select it, the name will appear where this says none. Now it'll say that filter, then you click on the white space there. That opens up another window that allows you to set parameters. So you have to set that you want to only apply that filter to option 5, right? And then once you've set everything, all the parameters, you click apply, and then that filter will be applied in full to your entire data set. Does that make sense, guys? We're
Yes.
not, go ahead. Yeah, somebody asked a question. Okay. So we're not going to do that now, but just be aware, your MNIST data set that I loaded on my website, it could be that when you download that file, it is, I believe it's CSV files, but it could be that that last label comes out numeric. So you will have to apply this filter, okay? Should be pretty straightforward. What else? What else? One thing I should say, I think that file is big, so I don't know. Sometimes Weka gives you memory, out of memory problems. So yeah, there's nothing you can do about it. I mean, MNIST, I should say, when you're doing machine learning, MNIST is not a real data set, a real world data set. MNIST is a academic, you know, for class. Your data sets are going to be much larger. What students do sometimes is they subsample the data set, so that instead of using 70,000 samples, they might just reduce it as much as possible until it fits in their memory. So just be aware of that. All right, so another thing. So in this case, because we have, go back here, we have 150 samples with 4 features, and each sample has a label. Setosa being one label, versicolor being another label, virginica being another label. We know that this data set is a supervised learning data set. Okay, we can apply supervised learning. That is, we're going to correlate the features to the labels, build a model, so that when we give it another sample, it'll predict, is it versicolor, virginica, or setosa. Now, one thing I should say is that Weka allows you to have a word here. So Weka is okay with this being a word, but usually what you will want when you have your data sets is that you want these to also be numbers. All right, so just be aware of that. So again, I remind you, look at the data type, numeric, 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 nominal. Sometimes you miss that little detail and then things don't work for you. Okay? Any questions? Can you guys hear me?
Yeah, I can hear you. I don't have any
Yes.
questions.
All right, great. Just checking that I'm still in the room. So now that we have the data set, so the way that, remember that I talked about that pipeline, right? So I talked about there being a pipeline in machine learning. And so the pipeline is reflected up here in these tabs. So really the first part of that pipeline would be pre-process here in Weka. So that just means, you know, I load my file, look at it, apply filters. Second step in the pipeline is, am I going to do supervised learning or unsupervised learning? So in this case, it's a supervised learning problem. So all I do is click. I already have my data set loaded, filtered, it's ready to go. Now I'm going to move to classify. And you can see that I just clicked on classify, and now I'm going to apply machine learning. If this label, species, was not nominal, and instead it was numeric, you would be able to reach classify, but you won't be able to access the supervised learning algorithm, okay? Be aware of that. So it is, you know, it's not gonna like it because it's expecting that to be nominal, to assume it's a label. All right, so we're ready now. what do we want to do? We want to apply one of those machine learning algorithms to our data. Now, if you remember, before I said that we need to split the data, there's actually 4 options here of different things we can do. Don't worry about these 2 for now. We'll come back to them. Don't worry about cross-validation. I need to explain that in another lecture. Instead, let's just focus on the last one, percentage split. So what that means is I'm going to split it, as I said, 80-20. Okay? I just have to specify 80 and that's it. It assumes the other obviously is 20. I need to specify what the label is, right? In this case, it would be the one that has a nominal species. Click on that. And all that's left is, so now I'm going to take the one. So what's going to happen is Weka will take the 150 samples, multiply that times 0.80. 120, I believe, is 80%. So that will be, it's going to select those randomly. And it's going to say, okay, I'm going to use 120 for training. I'm going to leave the other 30 or 20% for testing. But it's doing all of that behind the scenes so that you don't even have to do it. However, if you want to do it yourself and feed 2 files, we can do that as well. That's what these 2 up here are for, okay? But we're not going to worry about that yet. And then the last part is, the most, a very important one is selecting which machine learning algorithm do we want to use. Remember what I said, I gave you, when I was talking about the model, I said, oh, we might just want a line. Maybe we want a line with boundaries. Maybe we want a curve, right? A neural net kind of thing. So how do we do that? Where it says classifier, just click on choose. And there you go. So these are all your algorithms. For instance, here, naive Bayes, right? So you can try naive Bayes, that one. Okay, and if you hover over it, gives you a little bit more information about it. Usually with Weka, it already has preset default values. You don't even have to worry about the default values that much. So you click on naive Bayes and you would apply that algorithm. Go to functions, right? We have a multi-layer perceptron. A multi-layer perceptron is a neural net. Not a deep neural net, but just a neural net. However, it is not recommended to use this one because it's very slow. And as you will learn probably when you start doing your homework, I will ask you to use the multi-layer perceptron just so that you know that learning the parameters of a neural net takes a lot of computing power because it's a much more complex algorithm because it has a lot of parameters that you need to be learned. And so, that's the issue. Simple logistic, right? You can look at this one, all right? So simple logistic model, logistic regression. We have logistic here. Okay, it's another version. So you can try all of these. All of these are pretty much, the idea is that they're linear models, like the straight line that I talked about. KNN is another one. It's called IBK. The K just stands for the number of iterations, or sorry, not number of iterations, the number of K samples that you want to compare to. KNN is one, it's called a lazy algorithm because the training kind of happens in real time. You will learn how to write KNN from scratch. So hopefully with NumPy, we'll be able to do it so that, and without, so that you can see that difference. Okay. Let's see, there's a lot of algorithms here. I don't really use a lot of these. So yeah, I'm not gonna ask you to use any of those. Let's go to miscellaneous. None of those. Rules. Okay, we have no. And then I have trees, and then I have J48, which is a decision tree, and random forest. Oops. Random forest. which is kind of like if a tree is one element, a random forest is made up of several trees, right? Don't worry about understanding how they all work right now. I just want you to play with them and to basically compare them. Now, you might say, is that all of them? Well, it's not. That's not all of them, actually. There's more, but they're just not installed. So what happens here is that whenever you install Weka, it just installs the basic default set of algorithms. However, I'm pretty sure when you started Weka, it gave you a little screen that said there's a manager for installing more things, right? And so you kind of have to use that. You have to, for instance, do you want support vector machines? You can have it. There is a built-in support vector machines. This SMO, I believe is yeah, you can see that there. Support vector machines. It's kind of a slower version. And so on. So you can, in conclusion, you can add more algorithms just by installing them via the package manager. But for the homework, if you want install more, I'm really just going to ask you to use naive Bayes, multi-layer perceptron, you know, SMO, one of these logistic ones, KNN, IBK, and the trees. So J48 and random forest. Okay, use all of those algorithms to run your data. Now, does that make sense, guys? Are there any questions so far?
No, we're clear.
Straightforward, right? Okay, now that you've done it, let's go ahead and pick one. I'm going to pick naive Bayes. Naive Bayes is usually a very fast algorithm, but it's also not the greatest. And so what that means is that you can, if you want to just get a baseline value that comes out really quickly, you know, you run naive Bayes. And what that will do is it'll tell you what performance you can expect from your model. Okay, what performance. So for instance, you know, are the results going to be pretty good, pretty bad? Because you can expect that if naive Bayes is good, everything else is going to be even better. Or if it's not so good, you still have hope that other algorithms will do well. Now, if naive Bayes is pretty bad, it's possible that everything will be pretty bad because it's a problem of your data and your features. Okay, so remember at this point, all we're going to do because of the percentage split is the algorithm will grab the 150 samples. We'll take 80% of those to build a model with, let's say, naive Bayes. And then once the model is built, it's going to take the other 20%, run it through the model, make some predictions, and compare to the real values. Remember that in these 150 samples, right, in these 150 samples, all of them have, so if I go back to edit, every single sample has a label, right? During the training phase, we use both the features and the label. During testing, we only use, so let's say this is the test sample. We will only use 6.7, 3.0, 5.0, 1.7. We feed that into the model. The model will predict one label. Let's say it predicts versicolor. Then we compare it to the real value, which is also versicolor. It means that the model was correct. However, if the model predicted virginica and the class was versicolor, then obviously we have an error, right? And so the accuracy will go down. Is that concept clear?
Yes, sir.
Great. So now that I have naive Bayes here, I have my percentage split. I've already set the label. Let's go ahead and hit start. That's it, because I only have 150 samples. You know, my computer's a bit fast, and so I'm able to get results really quickly. Right? You can see that. Look at all the information I got. This is the information that's pretty critical to understand, right? These are all the performance metrics that you're going to get. So we will learn about this in a couple of weeks all the the equations of how this works, the logic, intuition, the why. But for now, intuitively, you want all of these values to be high. All right, they're all between 0 and 1. So for instance, up here, it says we had 29 instances, right, that were correctly classified out of 30. That was the total number of instances was 30. So there was one incorrectly classified one. Remember, those are the 30 from the test set. And so these performance metrics are only in terms of the test set. It gives you some additional values here. So the overall classification was 96.66, pretty decent result. Okay? In the real world, you will rarely get such good values. So what are the metrics? The metrics are precision, recall, F measure, and the accuracy. Okay? And then down here, we're going to have what is called the confusion matrix, which is also pretty good. So Weka also gives you the performance metrics on a per class basis and overall. So the fourth row here is overall for all. But if you just want to zero in on the type of label, setosa, versicolor, virginica, you can look at that specific row. So for instance, the precision was really high for setosa, really high for virginica, and then slightly less high for versicolor. That tells me that in terms of precision, the model has more trouble with the versicolor type. In terms of recall, the model did really well with setosa versicolor, not so good actually, 0.88 in relation to virginica. Now, you might ask, so what is precision, what is recall? We will define that really well in the next class. That's going to take a long time to define all of those concepts. The best metric that everybody uses for measuring, if you want to measure everything with just one metric, is the what is called the F measure. The F measure is a combined picture of everything. And so this is the one that usually we will look. So overall, the problem got 96% F measure. For each label, got 100% for setosa, 95 for versicolor, 94 for virginica. So that would tell me that virginica has the worst F measure. But still, they're all extremely good. ROC, we're not going to talk about that one right now, but this is another important one. Is this clear, guys? Those are what every problem that you do in supervised learning gets measured by this.
Professor, I have a question. When you're talking about the F measure, that has to relate it with, I mean, just the question, is there F values or what this thing is representing? What I'm learning out of the F measures.
Because it's going to take a long time. So for now, think of it this way. You know what accuracy is, right? I have samples, and they were supposed to be this. How many out of those 30, 29, were actually correctly classified? So it's easy to calculate an accuracy. It's 29 divided by 30, correct?
Right.
Right. So that's all you need to know now. Precision, recall, and F measure are more involved, and you know, I can't just say it now. I have to provide examples to give you more intuition. They basically relate to out of, you know, for instance, out of all the samples that I got, how many were correct? Versus the idea out of all the samples that I wanted, how many was I able to get? So it takes a little bit more discussion of it, okay? So for now, the rule of thumb is you still want those values to be pretty high, okay? But
so the max, the max, there can be one value of this, and everything less than that, I mean, it's not accurate as much as one. Is that what I'm learning on?
They're all basically like an accuracy score, except that they have more specific meaning that we need to get into. And the only way to really grasp that is via examples. So I need to take, more than a lecture. So that will be the next time we meet. I will go over the performance metrics. It's already posted on Blackboard, but I don't want, you're not gonna get it right away. Okay.
Okay.
So for now, the best thing that I can tell you is they're like accuracy, but they explore it more specifically. Okay. Sometimes, so I'll give you an intuition. So sometimes you just want all the samples in the world. You cannot miss one, right? And that's the classic example of like in medicine, right? You don't want to miss somebody having cancer, right? So you want to catch it. Versus a false negative where you thought they had cancer and it turns out they don't have it. So there's a difference between missing something that's really important like that and missing something that, there might be another scenario like when you're on Twitter, right? And on Twitter, you don't need all the examples of what people are saying about politics. You only need a few. And so your algorithm only needs to reflect its accuracy based on getting a few versus getting all of them. You see what I'm saying?
Yes.
Yeah, but as I said, that's a complicated thing, so we're really gonna have to, think about it later, okay? So for now, just the rule of thumb, as metrics, you want them to be really high. You want them to be around 100%. If you have a two-class, here, this is a three-class problem, but if you have a two-class problem, right? Let's say I just had two labels, Setosa and versicolor. And my accuracy, my F-measure, precision, and recall were all around 48%. Your model is terrible because statistically speaking, you could flip a coin and do better.
Yeah.
That's your, sell your algorithm to some company, a big box, and then just hide a person inside that just flips a coin and it'll do better, right? But if your model, precision, recall, F-measure, are all above 70%, oh, that's way better than flipping a coin for a two-class problem. Okay? Got it?
Got it.
All right, good. So the last thing, sorry, we missed a few minutes. So let me just take a few minutes here. The last thing is you're going to have the confusion matrix here. And the confusion matrix just tells you where something was misclassified. So for instance, remember we had the Virginica, right? Virginica, and notice that it's the class C, and 8 of those samples were classified as C, so they were correctly classified, but we had one misclassification. You see that? And it was classified as B, which is versicolor. So basically what you want is the diagonal to have numbers and the off diagonal to be all zeros, right? But in real problems, that's rarely the case. But the confusion matrix is really good at telling you where the system is getting confused, right? Because it tells, for me, I already know, oh, the problem is not with A, it's not Setosa, it's something with Virginica and versicolor that's confusing the machine learning algorithm, okay? And that's it. So you do that. I did this for naive Bayes. Then I can do that for IBK, which is KNN. I selected it again. What I'm going to do now, same parameters. I hit start, and you will notice that now there's going to be a second entry here. Click. There it is. And it's the same, right? Metrics are pretty much the same. It does, Iris will do well. You can see there, if I click on this one, I go back to the old one. Click on that one. So Iris will always do really well. I can do decision trees, J48, selected, again, default parameters. If you wanted to set the parameters, click on the white space, and there's a lot of parameters. Okay. Now hit for J48, boom. You have 3 now, 3 algorithms. Notice that this one is nearly perfect. Look, all values are 100. You will never get this in real life, or rarely, but, possible. Got it, guys?
Why J48 showing 100% accuracy?
That's like a philosophical question, okay? The short answer to that is that some models may be better for some type of data. And this data might be very, very good at a decision tree. You pick one, and then from there you can proceed to the next one, and then proceed to the next one, and so on. However, I should say this. Just because it did well on this data set, which is a sample of the population, doesn't mean that it's going to be perfect for the rest of the population, okay? Only through experiments can you really figure things out. Right now, it seems that J48 would be better. Remember, only for this data, not for old data, okay?
So can you explain in a tree J48 for the confusion matrix?
Sure.
I mean, it looks pretty much the same to me.
It's not the same. There's a difference. Look at naive Bayes. And now look at J48. What was the difference?
Can you go back for a second, naive Bayes?
Sure. Look at naive Bayes. Just focus on the confusion matrix, right? Just look at it.
Okay.
Now I'm going to hit decision tree. Look at what happened.
Yeah, I see that.
What happened?
The very bottom, whereas the C is, that one is gone under the B.
That's right. What that means is that decision trees had no misclassification. All C's were classified as C's, all 9. But in naive Bayes, it classified 8 of the 9 as C, 1 as a B. And that was
Got it.
And that's what the confusion matrix allows you to see sometimes. Don't worry, every time we do this, we're gonna look at these metrics. Okay, I'm gonna drill you on it. And as I said, later on, I will give you a lot more intuition. It'll make more sense. Why? Sometimes F measure is the appropriate measurement, but not always. Sometimes really what you should care about is precision, regardless of F measure. Okay? Or the opposite. Got it, guys?
Yep.
The last thing that I want you to do for the homework is, so you will do this. You will load those 2 files that I have below at Iris, the MNIST. One is train, one is test. Just grab train. You can ignore test. Do the split here. Run a few algorithms and get results. And then analyze those results, okay? That's all I want you to do. Look at it, that'll drive a lot of questions for you. And then when you come back in the next lecture, we will go over these metrics, a couple of lectures, and just really I understand them. The last thing you might want to do sometimes, and I'll wrap up the class with this, is you go to the Select Attributes tab, click on it, and what you can do here is that you can now say which features are the most important to solving or for that classifier, right? So for instance, if somebody is going to buy a really expensive car, well, there may be a lot of variables associated with that person, but certainly their income might be the most important, right? If they can afford it, they'll buy it. And so that's what this gives you. So all you have to do is select that you want a ranker. So I click on ranker. Then it suggests what method I'm going to use. So it's going to say information gain. And really, for now, don't worry about methods for ranking. There's a lot. But just always in search method, select ranker. So what it's going to do is it's going to grab all the features and rank them. Okay. I'm going to say use the training set. The class, I'm going to set it as species. Okay. And then now I'm going to click start. And you can see I hit start really quickly. Down here, it gave me the ranked feature. So what this means is that it's saying, for this type of problem, where I want to distinguish between Setosa, Virginica, and versicolor, there are some features that are more important than others. Okay, so based on what you see in your data here, Who can tell me what is the most important feature?
Header length.
Header length, right? Because it's 1.418, right? It is. That's just the highest ranking value. What is the least important feature of those four?
Sepal width.
Sepal width. That's it. Okay. So this is the homework that I want you to do. Just grab MNIST. Maybe even look for another data set. I mean, if you're interested, I think I provided actually another data set, I believe, in the Word document from UCI. I want to say I did. So analyze MNIST, maybe find another data set online, and just repeat what I did today, right? You know, get your data, make sure everything is there, run a few algorithms, look at the performance metrics, do the feature ranking, and get a picture of the machine learning pipeline. Now, we are not going to use a lot of GUI. We'll be doing a lot of coding, but you know, this is we can always go back to Weka to take a look at things. Okay, definitely a very powerful tool that if you do apply data science or do a lot of work in machine learning or data analytics, it's a tool that you will always have available. All right, so we're a little over time, so I'm going to stop here for today. Remember, I will create a Dropbox on the Brightspace for you guys to submit your homework. That is going to be due the Monday that we come back by 10 p.m. All right, so you have 2 weeks to submit this homework. Just create a lab report with all your results. It's individual, and that's it. I will create the Dropbox at some point later. Are there any questions?
Yeah, I just wanted to know if there was any of the algorithms that you wanted us to use, like the classifiers in particular, besides just like how many and which ones in particular.
So you want to know specific ones, you mean?
Yeah, which ones specifically do you want us to run?
The ones that I mentioned. So you could always download more and try those, but at least have naive Bayes, just because, as I said, naive Bayes is always fast. Gives you results. Do multi-layer perceptron, because you're gonna seek it. It's slower, so it's probably take a long time with your MNIST. SMO is SVM, one of these logistic ones. IBK, which is KNN. And then from there, I think nothing in meta.
The J48 and the probably random forest.
Yeah, that's right. And then yes, and then go to trees. And J48 is the name for decision trees, and the other one is random forest. Yes, that's a good number of algorithms. It's just really to practice and get acquainted with the process.
Okay.
All right. Great.
Mm-hmm.
Are there any other questions, guys?
Nope, that's it.
All right. Thank you very much. All right. So no class on Monday because it's a holiday, and then we will meet again next time to answer questions about performance metrics. We're going to do those slides and do this homework.
So do you want us to take a screenshot or just to download the whole whatever we done it?
On all these things, you have to show me evidence that you did things.
Of course. Okay. Thank you.
So take a screenshot and then write 3-4 sentences. So machine learning is not just about like producing numbers, right? It's about having conclusions. So you have to tell me, yes, the performance is so and so. This, so just write a little bit about it.
Okay.
All right, great. Thank you very much, guys, and I will see you next time.
Thank you.
Okay.
All right, you guys take care. Be safe.